Hi everybody, the last type of rock we're going to look at is metamorphic rocks. Metamorphic rocks have a history of change, okay, to metamorphose, to change. So these are rocks that have undergone change because of heat and pressure. Now, not enough heat to melt them, but just enough heat to kind of scramble and rearrange the molecules inside. So metamorphic rocks have gone through a change. Now, one of the really nice things about metamorphic rocks is that you are typically able to tell what type of rock it was in its last stage in the rock cycle. So granite turns into a metamorphic rock, and we know what type of metamorphic rock that is. Sandstone turns into a type of metamorphic rock. We know what that is. Limestone turns into a certain metamorphic rock. So we know where they go. Now, when we look at metamorphic rocks, we want to look at whether they are foliated or non-foliated. And foliated, if you think about foliation, like leaves, are when the mineral grains line up and lay flat. All right? Non-foliated is when the mineral grains do not line up and they're just all over the place. All right? They do change, they do come together, they do rearrange. That makes them metamorphic, but you have either the foliated or the non-foliated. So let's start off by taking a look at what that foliation means. So a foliated rock is going to be a rock, again, like I showed you, where they line up in parallel bands. Okay? Sometimes those bands are very noticeable. Sometimes those bands are not noticeable. But they're in there. We know they're looking like this because this is what that rock looks like. You're not going to get this from that. So we know that this is foliated. We also know that this is foliated. And again, it's kind of tough to tell, but this is made of little pieces of platy minerals. Basically, actually, it's made up of mica, muscovite and biotite mica. That's why it's got that shiny look. And they lay flat into a pattern like this. So foliated has this look to it, whether we can see it or not. And non-foliated has this pattern to it. This is going to be non-foliated. There are no mineral grains flattening and lining up in this one. This is going to be non-foliated. There are no mineral grains flattening and lining up in this one either. And this is going to be non-foliated. All right? So foliated, flatten and line up. Leaves, foliage, flat. These are non-foliated. They do not. So I do want to show you one or two kind of fun ones. So this is Phylite. And Phylite is typically, when you talk about it, it has a wavy, it is foliated. I'll tell you that much. And it is going to have kind of a silky sheen and a wavy foliation. So there's a wave kind of to this. So this one is sort of neat. And another one, this one is kind of neat, and people just really like to say this one because this is schist. S-C-H-I-S-T, schist. Be real careful when you say that around your mom and dad. They may not get the joke. All right? So this, which is a piece of schist, yes, I went there. This is also made up of mica minerals that are all flat and platy together. Now, the really fun with this is if you can see these dark minerals in here, those are actually pieces of garnet. So this is a mica schist with garnet porphyroblasts, and you don't need to know that word, but porphyroblasts that are found inside. All right, so pretty cool. I did find some mica schist with garnets up in Maine along the coast. I found some phylite with garnet in it up in Maine. This particular piece of phylite, these pieces, these are actually from Mount Washington in New Hampshire. So, just like the other videos, I gotta ask you a couple questions just to keep everybody honest. So when you look at a metamorphic rock, you want to look at one of two traits. The first is this one. So if your mineral grains look like that, what type of rock is it? We know it's metamorphic. We don't need the specific. We want to know the category. What type is that? All right. Is this rock foliated or non-foliated? Is this rock foliated or non-foliated? Okay, those are metamorphics. We don't have as many metamorphics around in this part of the state. We have a lot of sedimentary. Almost all of the rocks we have around here are sedimentary rocks. Mostly the metamorphics get brought in from other locations for like railroad beds or road beds, things like that. You go out to the other side of the state and you get into some metamorphics. Like this particular one is on the other side and more central to the state. And then to get into some of the igneous rocks, you actually need to travel down into some of the other locations. Virginia has some good igneous. This is actually a chunk of basalt from an extinct volcano called Mole Hill, Molehille, which is down in Virginia. So, yes, you can actually go to Virginia and climb up an extinct volcano. All right, take care, guys.